everyone. It's the middle of summer. It's currently 102 degrees where I'm at, so we're making ice cream for this science experiment. Ice cream has been around for a long time, and almost everyone likes it. It comes in so many different flavors, but it was first reported in this belief that the Roman ruler Nero invented ice cream. He would have snow mixed with fruity beverages to create a kind of sorbet dessert, and it's kind of taken off from there. Different flavors. We have the ice cream machine, and now it's one of the most loved desserts in the world. And the reason why we have ice cream is because of one scientific secret, and that is salt. Salt is a secret because it lowers the freezing temperature point when it's added to ice. The ice is not actually in the ice cream. Instead, ice and salt are going to surround the mixture, and that is how the ice cream will in fact freeze. The freezing of the ice cream is what we're going to be focusing on today because we are going to lower the freezing temperature of that ice. Normally, water freezes at 32 degrees Fahrenheit. If you were to add salt to your ice, so that there's 10% salt, your freezing point would drop to 20 degrees Fahrenheit. If you increased your salt to 20%, it would lower to 2 degrees Fahrenheit. So this helps the liquid freeze and below 32 degrees. And we have ice cream. All right, so let's take a look at the scientific method. Today we are all going to be scientists, and you may be thinking, I'm not qualified to be a scientist, but anyone could be a scientist if you follow these steps. So a scientist always makes an observation, forms a question, forms a hypothesis, conducts an experiment, analyzes the data, and draws a conclusion. So we're actually going to be moving through all of these steps in our experiment today. Let's take a look at the standards that this experiment will be covering. So the first standard is to plan and conduct an investigation to describe and classify different kinds of materials by their observable properties. This is NGSS 2 PS1-1. And the DCI is different kinds of matter exist, and many of them can be either solid or liquid. Depending on temperature, matter can be described and classified its observable properties. So we're going to take a look at our ingredients and decide if they're solids or liquids and what our end result will be. Our other standard for today is NGSS 2 PSI-4, which is construct an argument with evidence that some changes caused by heating or cooling can be reversed and some cannot. So specifically for this experiment, we are going to be changing the properties by cooling, and it will not be reversible. The DCI for that standard is heating or cooling a substance may cause changes, ice cream, that can be observed. Sometimes these changes are irreversible and sometimes they are not. All right, so let's dive on in. Ingredients that we're using for this experiment. We have ice and salt for the freezing process. We have our measuring utensils. We have vanilla, milk, and sugar. Pretty simple. Before we start mixing, we have some vocabulary words. So the first is freezing point, the temperature at which water changes to ice. This is the key in our experiment today. And then another vocabulary word is a sweetener. A sweetener is a substance such as sugar used to sweeten ice cream. This is very important also. Okay, so for our first standard, we're going to talk about what are solids and what are liquids. Solids are firm and stable in shape, not like liquid or fluid. Liquid, on the other hand, is a substance that flows freely but is a constant volume, having consistency like water or oil. So if we're looking at our ingredients, ice will not flow freely. That would be our solid. And then our ingredients such as milk and vanilla. For example, if I was going to take this milk, we need half a cup of milk for today, and I measured it. It will take the shape of the measuring cup. So it's no longer in this cylinder-like shape that is the milk carton. It is now in the circular measuring cup. That is a liquid. Same would be true for the vanilla. We're going to need half a teaspoon of vanilla. So if I were to measure half a teaspoon, It would go from this shape, it's flowing freely, you can change its shape easily. Half a teaspoon, so there we go. Those are our liquids for today. All right. Let's review our procedure real quick before I actually demonstrate it. So this is our procedure for today. I've listed out our ingredients and there's also pictures. So for anyone who is a visual learner, likes pictures more than just a bunch of words, here's our ingredients. We're gonna put them into a small sandwich-sized Ziploc bag, seal the bag, and then we're gonna put a smaller bag into a larger Ziploc bag, add ice and salt, shake, and my favorite step, enjoy. All right, moving on. Let's make ice cream. Let's dive on in. So first, I'm using this measuring cup as a holding for my smaller bag to add the ingredients. Otherwise, I would make a mess. Okay, the first thing I'm going to add is my sugar. I need 1 tablespoon of sugar, so I'm going to measure that out. A little too much. Okay. Then I'm going to add that 1/2 teaspoon of vanilla. Next, I'm going to add my 1/2 cup of milk. And perhaps the most important step of this experiment is to seal it. We want to make sure that this mixture will not spill out into the ice and salt. No one likes salty ice cream. So I'm just gonna mix that around just a tiny, tiny bit. All right, I have my larger Ziploc bag, and in it I am putting 4 cups of ice. So now I'm going to utilize this measuring cup. And math really plays into this because we're measuring, each one of these measuring cups holds 2 cups. So I'm going to fill it twice. That is my 4 cups of ice. Into the ice, I'm going to add my salt. Remember, salt is our big secret right here to lower the freezing temperature. So we're going to add 4 tablespoons of salt. So using my measuring cup and my math skills, I'm going to measure out 4 tablespoons. This measuring device holds 2 tablespoons, so I'll need to fill this twice. Sprinkle it in there, and 1 more. Okay. Now I'm placing my ice cream mixture, which is completely a liquid. We can see if I tilt this, it is freely moving, and I'm sticking it inside, positioning it in the ice. And I'm going to, again, most important step, seal the bag completely. I'm not worried too much about getting the air out of it because that air is going to help the ice to move and surround the ice cream mixture. Now, this is probably best done with teams, especially working with students with little hands. Their hands get so cold fast. You're going to shake this. Perhaps you put on some music and let them dance so that they forget how cold their hands are. And in about 3 to 5 minutes, this will be your final product. It is now a solid. The temperature, freezing temperature of the ice was lowered. It surrounded the liquid mixture, and now we have ice cream. So it's a solid. It no longer is freely moving. No longer classifies as a liquid. So spoon, enjoy. The kids will enjoy eating that. Before we wrap up, let's review our standards and what we learned from this experiment. So the standards that we covered were different kinds of materials exist, and many of them can either be a solid or a liquid. So we reviewed the properties of a liquid and a solid, and we classified our ingredients accordingly. And then the other standard that we covered was that heating or cooling a substance may cause changes. So we opted for cooling, and we changed liquid into solid. And we also observed that with this solid, this is our product now, we can eat it, and we can no longer reverse this change out we made. We can't pull the vanilla out or the milk out or the sugar out or the vanilla. It is a mixture now, and it's no longer reversed. So now, enjoy.